18.
The graphs are visual representations of data collected. The graphical presentation is easier to understand when a comparison is to be shown. The rise in population of a town per year, the rise or fall of production in a manufacturing unit, sales on various days of a week, etc., are easier to understand with graphical representation.
Coordinate axes. On a graph paper, draw two mutually perpendicular straight lines. The horizontal line XOX dash and the vertical line YOY dash intersect to each other at the point O, which is called origin. These lines are known as coordinate axes. The lines XOX dash and YOY dash are called x-axis and y-axis respectively. The plane containing both the lines' coordinate axes is called a Cartesian plane. On the RHS of the y-axis, every endpoint of a square on the x-axis represents a positive integer, whereas on the LHS of the y-axis, every endpoint of a square on the x-axis represents a negative integer. Similarly, above the x-axis, every endpoint of a square on the y-axis represents a positive integer, and below the x-axis, every endpoint of a square on the y-axis represents a negative integer. Quadrants. Two perpendicular lines, coordinate axes, divide the Cartesian plane into four regions called quadrants. Region, quadrant, sign of coordinates x or y, 1, plus, plus, x dash or y, 2, minus, plus, x dash or y dash, 3, minus, minus, x or y dash, 4, plus, minus. Ordered pair. A pair of two numbers a and b is called an ordered pair AB, with a at the first place and b at the second place. The order in which the numbers appear in the pair is significant. The ordered pair AB is different from the ordered pair BA unless A is equal to B. Thus, 1, 2, not equal to 2, 1. Coordinates of a point. On a graph paper, let XO, X dash and YO, Y dash be the coordinate axes. The two perpendicular distances of the point from the axis are called the coordinates of the point. The distance of the point from the y-axis is known as the x-coordinate, abscissa, and that from x-axis is known as the y-coordinate, ordinate of the point. Thus, an ordered pair 2, 3 represents a point on the coordinate axis as whose abscissa is 2 and ordinate is 3. To locate a point on graph, in order to locate a point P on the graph, draw PM perpendicular to OX and PL perpendicular to OY. PM is perpendicular distance of P from the x-axis and PL is the perpendicular distance of P from the y-axis. We call PL as x-coordinate and PM as y-coordinate. In the figure, PL equal to OM equal to 2 and PM equal to OL equal to 3. These numbers taken together constitute an ordered pair 2, 3, consisting of x-coordinate at P at first place and y-coordinate of P at second place. The ordered pair 2, 3 is called the coordinates of point P. If we take any point on the x-axis, that is, on x or x dash, then y-coordinate at this point is 0. If we take any point on the y-axis, that is, on y or y dash, then x-coordinate at this point is 0. For example, M, 2, 0, lies on x-axis and L, 0, 3, lies on y-axis. Example, plot the following points on the graph paper. 1, P, 3, 4, 2, Q, 2, 0, 3, M, 0, 2, 4, N, 1, minus 2, 5, L, 2, minus 3, 6. S, minus 3, minus 3. Solution. Draw two mutually perpendicular lines. Mark the horizontal line as XO X dash and vertical line as YO Y dash, where O is the point of intersection of these two lines. Choose a suitable scale on the x-axis and the y-axis and mark the points. To plot the point 3, 4, start from O. Move 3 units towards right along OX and then move 4 units upwards parallel to OY and mark the point. This will be the location of the required point P, 3, 4. For locating the point 2, O or 2, 0, start from origin and move 2 units towards right along OX. The point will be on x-axis as y is equal to 0. Mark this point Q, 2, 0. For locating the point 0, 2, start from origin, move 2 units upwards along y-axis. The point will be on y-axis as x is equal to 0. Mark the point as M, 0, 2. For 1 minus 2, start from origin, move 1 unit towards right along OX. And from here, move 2 units downwards parallel to OY dash. Mark the point N as 1 minus 2. Similarly, other points L, 2 minus 3 and S, minus 3 minus 3 are located on the graph as shown in the figure. Example. From the graph given below, write the coordinates of each of the vertices of the geometrical figures. Solution. The distances of a vertex from the x-axis and the y-axis represent the coordinates of the vertex. 1. The coordinates of L are minus 5, 2. The coordinates of M are minus 3, 4. The coordinates of N are minus 1, 2. The coordinates of P are 2, 4. The coordinates of Q are 4, 4. The coordinates of R are 3, 2. 3. The coordinates of A are minus 1, minus 2. The coordinates of B are 2, minus 2. The coordinates of C are 2, minus 4. The coordinates of D are minus 1, minus 4. Line graph. A line graph displays data that changes continuously over periods of time. To draw a line graph, XO X dash and YO Y dash are drawn perpendicular to each other. Independent variable is taken on x-axis, whereas dependent variable on the y-axis. We plot the points and join these points in pairs to get the line graph. Example. The runs scored by a cricket team in first 10 overs are given below. Over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Run 4, 6, 8, 13, 6, 10, 8, 2, 12, 10. Draw a line graph to represent above data. Solution. Draw two axes, OX and OY, and mark the same. We take overs along the x-axis and runs along the y-axis. Choose a proper scale. Here, 5 small divisions is equal to 1 run. Example. Given below is the population in 1,000 of men and women in a village in different years. Years 2005, number of men 10, number of women 9.2. 2006, 11.5, 10.6. 2007, 12, 12. 2008, 14, 14.5. 2009, 14.5, 13.8. 2010, 16, 14.5. Represent the above information by line graph. Solution. Draw two mutually perpendicular lines, OX and OY, as x-axis and y-axis respectively. Mark years 2005 to 2010 along the x-axis with uniform gaps in between. Population of men and women is taken along the y-axis by choosing a suitable scale. Let 1 centimeter be equal to 1000, y-axis. Plot the points for the population of men and join these points in pairs with dark lines to get a line graph. Now, plot the points of the population of women with the same chosen scale and join these points in pairs with dotted lines to get line graph. Above line graphs represent the population of men and women in a village during the period 2005 to 2010. Distance time graph. Example: the distance covered by a car is given below. Time in hours: 8 a.m. Distance in kilometers: 30, 9 a.m., 50, 10 a.m., 70, 11 a.m., 100, 12 noon, 130, 1 p.m., 170. Draw a graph representing distance-time relationship by taking suitable scale. 1. How much distance did the car cover during the period 9:30 a.m. to 11 a.m.? 2. What was the time when the car had covered a distance of 150 km since its start? Solution. In order to draw distance-time graph, we represent the time on the x-axis and distance on the y-axis. Let us assume that 1 centimeter on x-axis represents an hour and 1 centimeter on y-axis represents 20 kilometers. Plot the ordered pairs 8, 30, 9, 50, 10, 70, 11, 100, 12, 130 and 1, 170 as points and then join them by line segments as shown in the graph. The distance covered by the car during the period 9:30 a.m. to 11 a.m. is equal to 100 minus 60 kilometers, which is equal to 40 kilometers. The time when the car had covered a distance of 150 kilometers since its start was 12:30 p.m.